In this lesson, we will continue to explain the number systems. We first look at binary systems. We showed some bitwise values with the calculator. We will now look at the hexadecimal numbers. We use the X sign for hexadecimal numbers. Hexadecimal numbers are represented by the prefix 0x. On old computers, some letter and number values were usually displayed in groups of 4 when the screen was opened. They are hexadecimal numbers and use base 16. This can lead to confusion as numbers are written as double digits after 9. That's why we use the letters from 10 to represent these numbers in base 16. We can use a small x to make these letters small. You can also write hashtag between colons and X to show the hexadecimal representation of these letters. Let's open our calculator again and check that it is in programming mode. Our calculator displays bits unsigned. First, I set up our calculator to display base 16 numbers. So when we flip the bits from 0 to 1, the values will be displayed as base 16 numbers. Hexadecimal numbers are calculated over every 4 bits, and these bits reach a maximum value of 15. After 9, it continues as A for 10 and B for 11 respectively. We use the F character for the last number 15. This means that the value of the 4 bits is 1. If you set all bits to 1 in an 8-bit number, you get the hexadecimal number FF. You will remember this number from our previous lesson. If you convert it to base 10, you will see the value 255. Let's show the hexadecimal representation of the number decimal 30 on the calculator. First, I set all the bits 1 except for the rightmost bit to get the E value on the right side of the number. In this way, we will have reached the value of 14 as decimal. On the left side, I need the value 1. For this, I set the right bit to 1. This means the number to the fourth end is decimal 16. As you can see, we have confirmed the hexadecimal equivalent of the number 30 with the calculator 1e. If you convert it back to base 10, we can still see our number.